Well, here we are in section 1-3, and what we're talking about today is solving linear equations. You know, you've been solving equations for a long time. In fact, even as far back as, second or third grade, you saw stuff like this. And some of the frustrations that we have as teachers kind of come from that second or third grade time, when those kids who were great with math facts, and maybe you were one of them, maybe you were that kid in the mad minute, it was dynamite, but then we got ourselves into some solving equations, and not quite like these ones. You saw these ones, if you were good at the mad minute, you were great at this. You knew that 4 plus 3 was 7 because you know 4 plus 3. But the problem was you weren't solving it the way we solve things in algebra. So when we got to some algebra type skills, you had some struggles. So it said 4 plus blank is 7, and we remember that was 4 plus 3. But if it said 4.1 plus x equals 7.4, you maybe started to struggle because I wish those guys would have kind of tipped you off to this one back when you were younger. Subtract 4 on both sides and you get that 3. And if that's the way your brain thought when you did these, when you transitioned over to algebra, you did great. You just sailed right into it. So when you looked at this right here, there's two ways of thinking. And if you ask little kids, you'll find out there's two ways of thinking. Some kids will think, oh, 3 plus 6, that's what it is. Some kids will think 9 minus 6 is 3, and that's how they get the 3. The second kid is much better prepared for algebra. So we got to get our brain to think that way. Let's start with some vocab. Equations. Anytime you see an equal sign, you got an equation. Linear equations are like 3x plus 4 equals 7 or whatever. When we say an equation is linear, we're talking about an equation that the variable is to degree 1. And if the variable was to degree 2, it would be a quadratic equation, so a little different. A solution is just the answer. So if I said 3x plus 4 is 7, we would all solve 3x plus 4 equals 7 by subtracting 4 on each side and get 3x equals 3, and divide by 3, x equals 1. So the answer was 1. Equivalent equations are two equations that have the same answer. So if this one up here has an answer of 3x plus 4 equals 7, and I said something like 5x minus 2 equals 3, those both have the same answer. They both have the answer of x equals 1, so therefore they are equivalent equations. Now, there are some things that you guys kind of already know, and they are all the properties of equality. Things you can do to both sides of an equation that keep it equal. So if I said a equals b, well, a plus c equals b plus c. Or I subtract c from both sides, like I did here. Or on this one, because it's the multiplication property, I'm going to multiply both sides by c, as long as c is not 0, obviously. And on the last one, I'm going to divide each side. So we have add, subtract, multiply, and divide. Alright. Now on this next page, I like this. I found this little joke out on the internet. It says 2 plus 2 equals x. X equals 4. Algebra, complicating simple things. That is exactly how we feel sometimes, isn't it? So when we solve this, we have 3/4 x plus 15 equals 33, and we're trying to find x. Well, I always kind of described it as kind of peeling away from the x. I want to get stuff back away from that x variable. And I talk a lot of times about PEMDAS backwards. Okay? So if I'm trying to peel away from the x, I see if there's anything I can subtract or add from both sides. And on this one, it looks like I can subtract 15 from both sides. So now I have 3/4 equals 18. Now, is there anything I can multiply and divide? Well, I can multiply by 4/3. Now, remember what I said. There's no such thing as subtraction anymore. There's no such thing as division anymore. So all we have left is addition and addition of negatives, multiplication and multiplication of reciprocals, and then exponents and parentheses. So we multiplied each side by 4/3, which is the reciprocal. So 18 times 4/3 is going to be 24. Put a 24 right here. Does 24 check? Does that work? That's always important to check your work, right? How many times you heard that? So 3/4 of 24 is 18. 18 plus 15 is 33. Take a minute, do these checkpoints, and see what you get. Pause it, do them, and then I'm going to give you the answer. All right, hopefully you got A equals 1 for the first one, and Y equals 12 for the second one. If you didn't get that, now the good student in you should say, all right, I'm going to go back, I'm going to try that one again because I want to make sure I get this. I don't want to go in class tomorrow not knowing how to do these things because Mr. Emeott says that these things are review from Algebra 1, and maybe I need the review. So if you didn't get it, go back, try again. Okay, and so on to example 2 here. I put these scales on here. I think this stuff is important for when you are, kind of referring back to stuff that, teachers used to talk about. We have x plus 3 and we have 8. And if the scales are balanced, that means the weight on both sides are the same. So maybe let's call this ounces on the right and ounces on the left. If x plus 3 ounces is on the left and 8 ounces on the right, I know many of you are saying, oh, it's 5, it's 5, it's 5 plus 3 is 8. But we take the 3 ounces off of the left side, then the right side would go down. So we have to take 3 ounces off of the right side, and then that would make it go back up and level out. So 8 minus 3 would then be the 5. Hopefully that makes sense. All right. We have these examples here. I'll make my pen a little thinner. On these examples, we're going to use the distributive property, and to use the distributive property, I'm going to make this a little bigger. I always say, can I get a whoop, whoop? And then we have 3 times 3x is 9x. Whoop, whoop. And I get a 28x. And so if I combine my like terms on the right-hand side, don't forget that this is really plus negative. So it's 28 plus negative 31. I get a negative 3x there. And now I'm going to add 3x to both sides. And I get a 12x minus 6. And I add 6 and I get 27. So 12x equals 27. And I divide by 12 and I get 27 over 12, or 9/4. And you could call that a number of things. You could leave it as a fraction. You could put it into a decimal form. But, whatever is easiest for you. As a decimal, that would be 2.25. So we want to check that out a little bit right here. 9/4. X is 9/4. So I'm going to put 9/4 here, 9/4 here, and 9/4 here. Okay? If I take this piece right here and I multiply 3 times 9/4, I'm going to end up with 27/4. If I take the 2, 2 becomes 8/4. It's a little refresher real quick. 2 over 1 times 4 over 4. 2 times 4 is 8. 1 times 4. So I'm going to subtract those. 27 minus 8 is 19/4. And if I take a look at this one right here, this one is really easy because these two 4s cancel out. End up with 9 plus 3, which is 12. And if I multiply 31 times 9, it's 279/4. Remember, it's 31 over 1 times 9 over 4. All right. On the left side, I have 57/4. force. Okay. On the right side, this is 84 right here. So I got to turn that into force. So again, I'm going to take 84 and multiply it by 4 force. Now, why I keep doing that is 4 force is really 1. I'm just changing what is perceived to be by multiplying the top and the bottom by 4. It will still have the same value because I'm multiplying by 1. 84 times 4 is 336 force. So now I have right up here 336 over 4 minus 279 over 4 ends up being 57 over 4. So that checked out and that worked. All right, you folks go ahead and try checkpoints 3 and 4. Pause it and try that. Hopefully you gave a little whoop whoop action there to start. That's a little starter for you. And then solve it out. Alright. Tomorrow you'll be able to ask questions if you didn't get x equals 30. And on number 4, I hope you got x equals 1 over 10. Alright, if you have any questions, let me know tomorrow. That would be great. Have a good day.